Okay, everybody, this is Mathman here, and I've put up, what is it, 8 different videos right now on mostly on trigonometry. I covered that topic pretty thoroughly, although I didn't cover it completely. We could still do quite a few more problems in that area. But I thought maybe at this point I should introduce some concepts in algebra, because without algebra you really can't do trigonometry. You really have to understand some of the basics of algebra. So the way we plan to do it here is just to give you some ideas of what algebra is, without going through the rigors of a mathematician's way of explaining it. I presume here that you would understand addition, subtraction, and some of the rules of addition and subtraction, and multiplication and division. And that is a presumption that I'm going to make in this video. And basically, the way I look at algebra, and you can look up the, let's say, more precise or let's say technically correct definition for algebra on your own in Wikipedia or in some math book. But basically, I think of it as a form of mathematics that uses symbols for unknown quantities and uses sets of operational rules that, when these rules are applied to the symbols, it allows for the solution of the unknown entity, or a resolution to which conditions can be applied for a solution. So let's say, for example, we have a situation where we want to know what quantity, or what value, I should say, that when it's multiplied twice and subtracted by 52, the result is 72. Well, how do I go about doing that? Well, let's say this value, we don't know what this value is, so we can create a table, and we say the value, okay, and then we said when that value is multiplied by 2 times that value, and when that value 2 times that value has 52 subtracted from it, the result is 72. Well, without algebra, we have to guess. So we can set up a table and say that our value is 10. 2 times that value is 2 times 10, or 20. And then 20 minus 52 equals 72. But we know that's not correct. So we guess again. Let's guess a bigger number. Let's say 30. Because here we have 20 minus 52. 20 minus 52. 10 is, I'm sorry, what am I doing? 20 minus 52 is just a difference, 32, and it's negative. So we have negative 32. Negative 32. And that's not equal to 72 at all. We're not even close. So we're going to have to get a bigger number. So we guess 30. So 2 times 30 is equal to 60. And 60 minus 52 is now in a positive realm. And that's 8. But that's still not equal to 72. So let's go to a bigger number. Let's go to 50. 2 times 50 is 100. 100 minus 52 is equal to 48. And that's still not 72. So let's try 70. 2 times 70 is 140. 140 minus 52. Let's do that down here. I do it easier this way. This is 10, 13. That's 8. And 8. That's equal to 88. 88 and 52. Let's 10, 13, 14, 140. So you can see I checked my math there. That's too big. That's greater than 72. And that's not the answer, so we have to go smaller. So it's between 50 and 70. So now we have to hone in. So let's try 60. Because 70 is too big. That's our limit, upper limit. So let's try 60. 2 times 60 equals 120. And 120 minus 52 is equal to 10, 11. That's 8, 68. 52, 10, 11, 12. So 68 is not, it's still too small. So 60 is too small. 60 is too small, and so it's in between 60 and 70. So if we try right in between, well, let's take a look. What's the interval of 88 and 68? Well, the interval is 20. And 72, so let's look here. Here's 0, here's 20, and this is 10. 72 is 4. That would be 5, 15. 4 would be right there. So it's not on the upper end, which corresponds with 70. That corresponds with 60. So it's not in the middle. That's still too high. So that would be 65. 65 is too high. Well, let's try a smaller number. let's try 64. See, and we're still just guessing. We're just using logic here to guess. We're not using algebra. We're guessing, and it's taking us a long time. So let's say 64. 2 times 64. Well, that's equal to 128, and 128 minus 52 is 76. That's too big. Still too big. So 64 is too big. It's in between 64 and 65, because we knew 65 is, or 60, between 60 and 65. Well, 64 is too big, so that's our upper limit. So let's go right in between them and make it 62. So let's try 62. 2 times 62 is 124, and is 72 is 72. Okay, so we got it. We guessed it. But what if it was some fraction? You know, look at all of this. Look at all this that we went through just to guess the number using the set of rules that we were given. Algebra makes all of this guessing unnecessary, because what we do is we make the value, we treat that value as a number, even though it doesn't, we don't know what that value is. We call that value, let's call it X right now, just for the lack of anything creative or innovative. So let's say the value we're looking for is, we call it X. So let's write it out in full equation form. We said that this value, when multiplied by 2, so 2 times X, and we subtract 52 from it, is equal to 72. That was our set of conditions. And we went through that table of guessing. Well, here we have an equation. And now we will apply the rules to the rules of algebra to this equation. Now, the rules basically, I think the most fundamental rule of algebra is that when we have an equation, that whatever we do to one side, we must do to the other. We got to think of it as a balance, kind of like a balance. And if we have a lump there and a lump there, and they weigh the same, that balance is tipped. But if we add more to the one side, then the balance tips. So to keep the balance flat, that whatever we add to that one side, we got to add to the other. So that's the key rule to what for algebra, in an algebraic equation. If we add something to one side, we must add that same value to the other side to keep the balance. If we multiply on one side by a certain amount, we must multiply on the other side that same amount. And that's how we keep. You see, this equal sign is the pivotal point of the balance. And so whatever we do to the one side, we must do to the other. But what do we do to narrow down you know, we have a number of things here. What if we start getting rid of these things, these numbers, and simplify it as much as we can? Well, how do we simplify this? Well, it'd be simpler if 52 wasn't there. So what if we add 52 to each side? That gets rid of the 52. So 2 times x minus 52 plus 52 equals 72 plus 52. Now we've gotten rid of the 52 on this one side, and it's been added to that other side. So we have 2 times x equals, that's 124. Now, what we really want to do is isolate this x, that value, to make it stand alone. And that's how we solve for that value. Well, what do we need to do to make this value stand alone? Well, if we multiply both sides by 1/2, remember, whatever we do to one side, we must do it to the other. So if we multiply by 1/2 and 1/2, we find that 2 times 1/2 is 1. So we have x standing alone here. And we have 124 divided by 2. And that happens to be 124 divided by 2, that's 6. 6 and 2, that's 62. So x, now, there we go. That's our solution. We found the value that we have been looking for. So rather than going through a whole bunch of guesswork, we actually substituted a symbol for the number we're looking for, and we apply the rules of mathematics to it in such a way that we isolate for this value. So let's try another one. Let's try another equation. That was a simple equation. That was a linear equation because x wasn't a high order. It was only an order of 1. And when I mean order, I mean, let's say that's x to the 1, x squared equals x times x, and this is 1 times x. X to the 3rd equals x times x times x. And this is the order of the equation. This is order 1. This is order 2. And this is order 3 because of the power of x. And we also call this linear. And this is a quadratic. Or order 2, and so on. They have different names for these things. So let's take a look at another equation. And the answer doesn't always have to be positive. Let's just shoot from the hip. Let's say we have a value x when multiplied multiplied by 3 minus 6 times the same value plus 100 is equal to 30 times x plus 600. Wow. Now that looks pretty complicated. So here we can factor out x. We can say x times 3 minus 6 plus 100 is equal to 30 times x plus 600. Well, 3 minus 6 is minus 3. So we have minus 3 times x plus 100 equals 30 times x plus 600. Now remember, the goal is to isolate x. And here we have x on two sides. So what do we do to get rid of x on one side? Well, I think if I add x or 3x to this side, then that cancels that out. But if I do that to that side, I must do it to this side. So I go 3 times x minus 3 times x plus 100 equals 30 times x minus, or I added x on that side, so I got to add 3x on that side plus 600, and then the x goes away on that side. I have 100 equals 30x times x plus 3 times x plus 600. You can see things are getting a little simpler. Now we can factor that x out, and we have 30 plus 3 times x plus 600. Okay. And we have 100 over here. Well, we want to isolate x, so how do we do that? We can subtract 600 from there, and we can subtract 600 from that side. So minus 600 plus 100 is minus 500, and that's equal to 30 plus 3, or 33x, and these cancel. And so we have 33x equals minus 500. And all we need to do is divide by 33 on each side, and we can isolate x. So minus 500 divided by 33 equals 33x divided by 33, and that goes to 1. I'm running out of board room. I wrote too big. Okay, so that's what our equation runs down to. And we can start from the top. I can bring this up here, minus 500 over 33 equals x. And that's the solution. And because there's no common factor, I don't think that there's a common factor. Let's see, 500, I don't think 3 goes into 500. 3, 2, I mean, 3, that's 2, that's 6, 18, that's 2, so it's 3.6666. That goes on. So it's not a nice fraction. We can leave it like this. So we can just swap things around as long as the equation is, it's like if we took the lump from here and put it over there and that one over there, the balance, as long as they weigh the same, doesn't change. So minus 500 over 33. And that's the answer for that particular set of conditions. Oh, and you know, I erased the original equation, so I can't plug that in to verify it. Really, what I should have done was I should have kept the original equation and then plug in that value to see if it works. So let's try another one of a similar nature. Let's say minus 5 times x plus 2 times x minus 100 is equal to 500 plus 20 times x. Let's keep that equation. Again, the whole point is to simplify this by rules of addition and multiplication, and remembering that whatever we do to one side of the equation, we must do to the other side. We're going to be fine. We're going to be able to isolate x. So here we factor out x, and we have x times minus 5 plus 2 minus 100 equals 500 plus 20 times x. Now, I can do multiple things as long as in one step, as long as I keep track and that I do whatever I do on the one side I do to the other. But I'm just doing one step at a time. I'm only doing one thing at a time so that you can follow. But I could do a number of things. Like I could have done the addition of this and add 100 on this side and on that side, all in one step. So that way it shortcuts or shortens the equation. It's whatever you feel comfortable with. I'm doing it step by step so that you can see the process of what we're actually going through. So that is minus 5 plus 2 is minus 3 times x minus 100 equals 500 plus 20x, 20 times x. Usually we just drop the multiplication sign, that dot, and just write, let's say 20 times x is equal 20 dot x is equal to 20x. It's just a shorthand. We know that that means 20 times x. We don't have to write it out. I'm writing it out just for the ability to follow's sake. So, what do we want to do? We can add 3x to each side to get rid of 3x on that side. So we got plus 3x minus 3x minus 100 equals 500 plus 20x plus 3x. These cancel. We got minus 100 equals 500. And we can factor, that's plus 20 plus 3 times x. And we can subtract 500 from this side and from that side to isolate the 500. So here we've got minus 500 minus 100 equals 500 plus 23x minus 500. So that cancels. That is minus 600 equals 23x. If we divide by 23 on both sides or multiply by 1 over 23, we isolate x. So we can go 1 over 23, and this is 1 over 23. That cancels, and we have minus 600 over 23 equals x. Now, unlike the last time, we're going to plug this in to the original equation and see how it works for us. Okay, so that's our answer for x. So, minus 5 times x, which is minus 600 over 23, plus 2 times minus 600 over 23 plus 100 equals 500 plus 20 times minus 600 over 23. Okay, well, here we have minus 5 times 6 minus 600, so that's 3,000 over 23 plus, that's minus 1,200 over 23 plus 100 equals 500 plus, okay, 20 times 600. We got 0, 0, 0, 0, 0, 12, 0, 0, 0, 2, that's 12,000. So that's negative, so that's minus 12,023 over 23. Okay, now we just got this mess of math. Okay, so these are over the same, so that's 3,000. We got the same denominator, so 3,000 minus 1,200, 0, 0, that's 10, 2, 8, and 1. So that's equal to 1,800 over 23. 1,800 over 23 plus, now we've got to, that takes care of those two terms. We got to turn this into a fraction, so we multiply top and bottom by 23. So 23 over 23 times 100 equals, and we need to do the same over here, negative 500 times 23 over 23 minus 12. Well, this is plus. That's a plus 5. I made a mistake there in copying. 12,000 over 23. So everything is over 23 now. And 100 times 23, that's 0, 0, 3, 0, 0, 2, 0, 0, 3, 2. Okay, so that's 23. Did I get that right? 0, 0, 3, 0, 0, 2, 0, 3, 2. So that's, yep, that's correct, 2300. So we have 1800 over 23 plus 2300 over 23 is equal to 500 times 23. That's 0, 0, 15, 0, 0, 10. That's 0, 0, 5, 1, 1. So that's 1, 5, 1, 1, 5, 0, 0, 23 minus 12. Oh, I'm sorry, this is a minus. That's got to be a minus. Minus 12,000 over 23. See, I didn't keep my signs here. That's what you have to do. You have to keep your signs correct. That's important. I like commas because they differentiate. So the difference between 2300 and 1800, whoops, minus 1800, 0, 0, this is 13, this is 1, that is 5. So it's minus 523 is equal to all right, 11,512,000 is 0, 0, that's 10, 1, 500 is equal to minus 523. So it works. This holds. We get the same answer. We kept the balance. So we found that our answer, minus x equals minus 600 over 23, is the correct answer. And we were able to confirm it. So now, sometimes we're given something. Let's say, before we do that, before we do systems of equations, let's take a look at something. Let's look at what René Descartes discovered, and this idea of algebra. It was first invented by the Indians, and they traded with the Arabs, and the Arabs called it algebra after one of their mathematicians who used it, but it was the Hindus, they gave it to the Arabs, and then the Arabs introduced it to the very backwater Europeans. So the Chinese and the Indians and the Arabs were way ahead of us in mathematics and science and so on. So let's say we have an equation that's given to us. We got 2, 5. No. Let's keep it small. 2 times x minus 3 equals 0. Okay? And basically, we want to solve this. Again, it's a very simple case. We take 2x minus 3. We add 3 equals plus 3. Those cancel. 2x equals 3. And if we divide by 2 on both sides, we have x equals 3 halves. So we can verify that x equals 3 halves. X equals 3 halves. So we have 2 times 3 over 2 minus 3 equals, well, that cancels, and we got 3 minus 3 equals 0. And that confirms it. So that is the answer. But I also mentioned that 2x minus 3 equals 0 is also what we call a linear equation, because this is only a power of 1. X is a power of 1. And we can think of this function as a function of x. And we say that the function of x is 2x minus 3. And we want to know when what the values of f of x for different values. So let's make a table. Okay, so f of x is equal to 2x minus 3. And so we have x and f of x. X is 0. So when x is 0, f of x is minus 3. When x is 1, then f of x is minus 1. Whoops. That's not very neat. Minus 1. When x is 2, we have 1. When x is 3, we have 3. When x is 4, 8 minus 3 is 5. And what do we notice about each of these? They are a difference of 2. So the difference in x, or difference of f of x, is 2 for each x. Let's say for each value of x, the change in the function's value is increased by 2. So if we look at 5, we have 10 minus 3 is 7. And you can see it's a difference of 2. Well, what if this was 7? That's 14 minus 3 is 11. Well, that's a difference of 4 because we skipped 6. And so the delta now becomes 4. But there's a steady relationship here. So if we say this is x, and we say this is the value of the function for a given x, we got 1, 2, 3, 4, 5, 6, 8, 9, 10. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, when x is 0, and this is 0, we know that the function is minus 3. So it's back here somewhere. If we extend this back 1, 2, 3, so it's back there at minus 3. When x is 1, it's at minus 1. So right here. And when it's 2, it's at 1. Okay, when x is 2, the value is 1. Let's see, I'm sorry. I screwed up. When x is 0, sorry about that, guys. Minus 1, minus 2, minus 3. Okay, when x is 0, we got minus 3. When x is 1, we have minus 1. So it's right in there. This is 1. When we have x is 2, we have 1. When x is 3, we have 3. I'm just doing this by eyeball. When x is 4, we have 5. So 5. And when x is 5, we have 7. See, 5. What did I do here? X is 4. The value is 5. When x is 4, the value is 5. Okay, right there. X is 3. The value is 3. So it's right there. 5 is 7. So it's right up in there. If we took a ruler and connected the dots, we get a line. That's not a very straight line. We get a line if we pass the ruler through the points. That's 3, we got 4 points. 5 is at 7. So it's up there. Okay, so, and 4 is at 5. So we have 5, 7, 4, 5. We have 3, 3. We have 2, 1, and so on. We could have fractional points, in fact, between 0 and 1 on a number line. We can have 0.5, 0.75, 0.25, and we can divide it up any number of ways we want into eighths, 1/8, 2/8, 3/8, and we can have 16ths, and so on. You can see how the ruler is divided up into measurements of that sort. And in fact, you can come up with an infinite number of divisions between 0 and 1. And we call, when that number of divisions is infinite, we say that the line is continuous. It's unbroken. And so between 0, 0, and 1, we can have any value. So we can say that the line here is continuous. It's unbroken. But we only use integers here just to give us an illusion. In reality, a mathematician's going to say, we really don't know what's happening between 2 and 3, but in reality we do, because the rule is it's given, and if it holds for these values, it's going to hold for values in between also. We just make that logical assumption. So we can pretty well believe that this line represents this function when we graph it. So this is what René Descartes realized way back in the 1600s, and we call this the Cartesian coordinate system in his honor. René Descartes was a famous mathematician as well as philosopher. You may remember, I think, therefore I am. So anyway, we have this f of x, or function of x, and it can be any kind of function of x. It could be 3x squared minus 9, and we could plot that, make a table and plot that, and we're going to see that it's going to be some kind of a parabolic function like that. A second order. Third order plots even more differently. Third order does something like this. We got x to the third like that. X squared, you get a u. X, you get a line. So these are the different things. And then when you get x to the fourth, you get another u. And then x to the fifth, it gets even more funky. You get these changes in curves. They call inflection points. And the inflection points reflect the order of the function. So no matter how complicated the function may look, it's all going to have some general behavior that is described by the order of the equation. And this is typical of a linear equation. Now you can have lines that go like this, or like this, or like this, or like this. You can have all different types of lines. You can have one that barely... It all depends on the equation. Another way we can write f of x is y. Y equals 2x minus 3. And then we can name this the y-coordinate system, the y-axis. So we have xy axis, and we can say what happens when y is 0, 2x minus 3, and for any, we can find any x for any value of y. So for example, if y is 25, let's say y equals 25, we have 2x minus 3, and now we can find the value of x for 25. So if we add 3 equals 2x minus 3 plus 3, those cancel. We have 28 equals 2x, and we multiply by 1/2 on each side, and we have x equals 14. So when y is 25, x is 14. So we can find any value of x for a given value of y. So we can think of y as being f of x. Now that we have this, sometimes we have two lines. Remember in geometry, if you have two lines that are parallel, they never cross, they never meet, they just go on forever. That's a very special class, because most lines are not parallel. Most lines will intersect at some point. So, what if we have two equations? Y equals 2x minus 3, and we have, let's say, y prime is equal to 6x minus 8. Okay, well, we would like to know the value x where they meet. So let's take a look at that problem. And just a second here, I lost my screen. I always lose this screen. Okay, oh, we're back again. So we want to know where these two lines intersect. Well, they intersect when they're at an equal value of y. So we say y is equal to y prime. And that would be when 2x minus 3 is equal to 6x minus 8. And if we subtract 2x from each side, we've got minus 3 equals 4x minus 8. We add 8 to each side, and we've got 5 equals 4x. Now we divide both sides by 4, and we have 5/4 equals x. And that's the x value where the two functions are of the same value. That's where their lines intersect. So we have, let's try 2 times 5/4 minus 3, and 6 times 5/4 minus 8, and that's 10/4, and we got to make everything into the same fraction, so we have 10/4 minus 12/4, and that's equal to minus 2/4, and that's equal to 30/4, and minus, and that's 32. Whoops. Darn it. 32/4 equals minus 2/4. So they are the same at x equals 5/4. So y equals y prime equals, and I can reduce that to minus 1/2 when x is equal to 5/4. So it's pretty simple to figure out where two lines intersect. There's something here that I didn't cover, and that is when we take a look at this equation. Okay, I need to get some light in here because the sun's going down. Oh, dearie. Okay, so now we have y equals 2x minus 3. Well, we call this the slope, and we call this the x-intercept. And that is the value where the function crosses the y-axis when x is 0. That's the value for when x is 0. So when x is 0, y equals minus 3. So that's down here. That's our intercept. And you can see that this is where the line crosses the y-axis. And we call this the slope. 2 is the slope. And the slope is how steep. Now, if we say something has a very steep slope, that means the number is big. So y equals 20x plus 3. That means it's very steep. When y has a, let's say, 1/100th of an x plus 3, it's very gradual. In fact, this slope can be negative. Y equals negative 5x plus 2. And that means the line has a downward slope. So when the slope is negative slope, the line goes down from left to right. Positive slope, the line goes up from left to right. Just some basic principles to understand. Now, why do we call it the slope? Well, let's take a look. Here, the slope of something we take a look on a coordinate system. That's y, x. So let's look at 2 points. We've got a distance x and we've got an elevation of y. And so we say the slope is the change in y over the change in x. So if we start at x1, we're going to be at y1. If we have x2, we're going to be at y2. So the slope, we're just going to call m, because it is a single number, is basically the change in y. Oops, sorry. Change, that means change. That whenever you see a triangle like that, that means change. The change in y over the change in x. And that means y2 minus y1 over x2 minus x1. That's the change in y over the change in x. And in this case, here we have x is 3, so we're going to look at m here. Okay, so we got the change in y. So when x is 3, y is 3. When x is 2, y is 1. And we have 3 minus 2. That's the change in y over the change in x for this function. And what do we have? We have 3 minus 1 is 2. 3 minus 2 is 1. And that's equal to 2. And remember, our function was y equals 2x minus 3. And no matter where we go, that slope isn't going to change any. So let's make 5 and 7. So let's say x is 5 and 7, and we have, let's say, x2, and x1 is 2 and 1. 2 and 1. Okay? Remember, this is x coordinate, that's the y coordinate. So the change in x, or the change in y over the change in x equals m equals 7 minus, whoops, what am I doing? 7 minus 1 over 5 minus 2. and that's equal to 6 over 3, and that's equal to 2. So no matter how we do it, we always end up with a slope of 2 because the line is, it's all one line with one slope. It also reminds us of our trigonometry. Remember the right triangle in our trigonometry, and we got y and x, and we have y over x, and we call this r. It's also called the tangent of the angle. And this line, when it makes an intercept with the x-axis, makes an angle with it. And this change in y over the change of x is the tangent of the line. And it just basically follows the line. And other functions that are not so, let's say, not so smooth, the tangent, the change in y over the change in x, may change depending on where you are on the function. So that's a tangent line at this point, that's a tangent line at that point, and tangent line there. And we're getting a little ahead of ourselves, but that's getting into the concept of so at this point, I think we've done a number of things to give you an idea of what algebra does. We didn't go into tremendous depth. For example, we didn't plot the higher order functions. We didn't solve higher order functions. Well, before we go, why don't we just take a look at solving a square? And what we want to do is we have 2x squared plus 3x equals 15. And we want to find a value of x that will solve this equation. Well, again, we can create a table that we can guess and plug in numbers and see if we can get this result. But one thing that we should recognize is that when we have a single order equation, there's only one answer. When we have a second order equation, we have two answers. And when we have a three order equation, we'll have three answers for the condition of 2x squared plus 3x minus 15 equals 0. There will be two answers for that. It will cross the x-axis twice. If we have a third order, we're going to have three solutions. So that is the difference between a linear equation and higher order equations. Now, in this, we have a special formula called the quadratic formula, or the quadratic equation. And basically, let's say we have ax squared plus bx plus c equals 0. That is a quadratic equation. And there's what they call the quadratic formula that can be derived to give you a solution for this, a nice simple solution. And basically the formula works out where we have x equals, like I said, there's always two solutions, minus b over 2a plus or minus 1 over 2a times the square root of b squared minus 4ac. That's the quadratic formula. So in this equation, we have a is 2, b is 3, c is minus 15. So x is equal to minus b minus 3 over 2a, 2 times 2, plus or minus 1 over 2 times 2 times b squared. That's 3 squared minus 4a times c. And that is equal to minus 3/4 plus or minus 1/4 over 9 plus 8 times 15. That's 48, 12. That is 120. So that's the square root of 129. Square root of 129. And square root of 129. Okay, so 10 squared is 100. 20 squared is 400. We got 129. So that's 11 squared is 121. 12 squared is 144. So it's in between 121 and 144, so it's 11 something. Let's say 11.2, 11.2. So we got 4, 2, 2, 2, 1, 1, 2, 1, 1, 4, 4, 5, 2, 1. So it's bigger than 1.2. And so 1.3, 11.3, 1.3, 11.3, that's 9, 3, 3, that's 3, 1, 1, 3, 1, 1, 9, 6, 6, 7, 2, that's 128. So it's about approximately 11.3. We're just going to approximate right now. So that is approximately 11.3. So x is equal to minus 3/4 plus or minus 11.3 over 4. And we have our two answers. And that's where the equation crosses the x-axis. And again, for a quadratic equation, it's going to cross there and there. Those are the values where the function is 0. It doesn't always have to be 0. You can have different forms of a second order equation such that it doesn't cross the x-axis. But we'll get to those. Those are special cases. And we'll get into those a little bit more in depth. But I wanted to show you this quadratic formula for solving the second order equations. So this is just a start, an introduction into algebra, what it's about, what you can do with it, and we're going to call it a night now for this video.